Right. Hello everyone. So Kevin asked me whether or not I wanted to do a lightning talk, and I said yes. What should I do it on? And he said, "Oh, just pick something random." So obviously random numbers. And so then I had the title, but didn't really actually have any content. So I started looking into random numbers, and it turns out to be quite a big topic. So this is sort of a bit of a random selection of things to do with random numbers. So I thought we'd just go from the absolute basics to how you use random numbers in C#, a bit about how you can generate your own random numbers and what makes a good random number generator. But there's loads of other stuff beyond this sort of 10, 15 minute talk. Zoom in a bit. Okay, so starting with the sort of from the absolute basics. Project. So you start off by declaring an instance of the random number class. That's your random number sequence generator. That's going to give you your random numbers. And then the simplest method to call on that is just next, which is going to give you the next random number. And it's going to be an integer, so it can be anything in the integer range. So that's our number that comes out there. So a more useful thing would be to actually give it a rate, say sort of the maximum minimum values you want it to give you. So I'll just change this code slightly. So it takes two parameters, a max and a minimum. So you could consider if I'm flipping a coin, you might say one's going to be head, two could be tails. And we're just going to run this 10 times. So the first thing you notice, is giving you ones every single time through that loop. And the reason it does that is, so we're giving it a maximum and minimum values. And the minimum is inclusive and the maximum is exclusive. So it means it's going to be 1 or greater, but less than 2. So that's sort of a bit of a gotcha if you haven't used it before. So if we wanted to simulate rolling a dice, for example, we put a 7 in there. So it's then between 1 and 6. And then you can see you get a good range of numbers. So that may look a bit of a weird way of working, but one of the things it is quite good for is if you're picking random numbers from an array, or random entries from an array. So we keep an array of suits. And hearts. So we're just going to pick a random entry from that. So in this case, the lower bound of an array is 0, and then we can just use its length as the upper bound, because the number is always going to be less than that length. So if I can... And there you see it's picking the 4 different values out. So the other methods on so we've seen the main one, which is picking a integer. There's a couple of other methods on there which we'll have a quick look at. So you can do next double, which gives you a number between 0 and 1. And there's also a next bytes. And this one takes an array of bytes and populates all the entries in that array with a random number. So we can do that as well. So we've got an array of 10 bytes, so there will be 0 to start with. see both of those methods on it. So you can see at the top there, hopefully, that's our random double between 0 and 1, and that's our array of bytes. For each of those 10 entries, we know what values. So what kind of things can you do with random numbers? Well, you can use them for things like machine learning and other algorithms such as that. Obviously, you can use them in games. And one of the things I came across is you can actually use it to calculate the value of pi. So the way you do this is you draw a square and then you inscribe a circle within that square, and then you just pick random points in the square and you count how many of them fall inside the circle, how many are outside the circle, divide one by the other. So that ratio then gives you pi. And so if I just do it 1,000,000 times, I think it is, you can see it's counted how many fell inside and how many outside, and I got 3.14, which is getting towards pi. And you can see this graphically as well. You can see building up, and the more times you do it, the better your value is going to be. So it starts off quite poor and then gets better and better. So interesting, you're never going to get exactly to pi because the random number generators in computers are a bit biased, so they're not actually completely random. So you get some discrepancies. So at the York Code Dojo back in November, I think it was, we were implementing card games, and so games are a good example of using random numbers. So you might want to shuffle your pack of cards to play your game. So one of the games I did was higher, lower. So I've shuffled the pack, taken the first card off the pack, and it's a 3, and so then you guess whether it's going to be higher or lower. So it's probably going to be higher, probably going to be lower that time, and so on. And each time you play the game, I generate my random numbers and I shuffle the pack in a different order. But what you might want to do is you want to replay the same game again, in which case you want to shuffle the pack the same way. And that's where it comes into seeding number generators. So your random number generator always generates numbers in the same order, in the same sequence. And it has an initial seed which says what that sequence is going to be. So when I say try this game again, I supply the same seed to the random number generator. So my pack's going to be shuffled in the same way, and so I'm going to get the same cards again. As you can see there. So we can see an example of that as well. So I'll just do a quick loop, and then it's on my loop. So this time I'm going to seed my random number generator 1, 2, 3, 4, 5. I'll generate 10 numbers. I'll do dice rolls again. And bring on a couple of blank lines. So this time I'm going to, so I've created my random number sequence again. This time it's set to 1, 2, 3, 4, 5. I'm going to generate 10 numbers, and I've got it in a loop, so we're going to do it more than once. And so the first time it runs, it gives us those values, and the second time I get the same values because I'm using the same seed. So my random number generator is now always going to give out the same set of values. So the question is, what was happening before when I wasn't specifying a seed in those first examples? What was it doing to generate the seed? So if we can look at that. So I've got the same idea as before. So I've just got a loop where I'm going to go round, I'm not specifying a seed. I probably want to put that in there for the moment. So I'm not specifying a seed. I'm going to generate a random number, and I'm going to do it 1,000 times. And I've written it in 2 different programs, and as you can see, they're identical programs. So I'm going to run them both at once. This demo is a bit hit and miss, but we shall see. So it's doing 1,000 numbers. So hopefully you can see a difference here. So in console app 1, we have what looks like a random set of numbers. And in console app 2, we have less random numbers. And you can see there's a sort of, it repeats the same number several times. And if I ran these two again, we'd get the same result and the same way round. So anyone going to hazard a guess what the difference is? So the difference is one of these console apps is .NET Framework and the other one's .NET Core. And in .NET Framework, it used to use the number of ticks since the machine started up to read the to seed the random number generator. So if we change the framework version to do the same, which is that one. So it's tick count. So you can see now, neither of them are providing a particularly random set. And the problem here is simply that this loop is going faster than the tick count's increasing. So I'm seeding the random number each time with the same number. So it's random source with the same number each time. So the recommended solution was just simply to, so this is the framework version, is if you just move your random number object outside the loop. So then you only set it up once, and then you're not constantly reseeding it. And yeah, so the way they fixed it in the new version is internally it actually has its own random number generator inside the random number generator. So it picks the next seed is actually the next random number. So that's that. So that's how to use random numbers in C#. The next thing is sort of a bit behind the magic of how you actually generate random numbers yourself. So these are called pseudo number random generators, PNRGs. So there's no real magic involved. It's a function where we're passing in our seed. It may internally have some state, and then next time you call it, it generates a random value. So there's nothing else getting fed into this. It's just a function with one input and possibly some state. And the first version was called the middle square method. Right. Slide a bit bigger. So the description is not all that helpful. So basically you start off with a 2-digit number and you square it so it becomes probably twice its length, and you pad it with zeros if it isn't, and then you just take the 2 middle digits out of that. So probably makes more sense if I show you that running. So I've started off with the number 42. So you square it, which gives you 1,764. I don't need to pad it because it's already 4 digits long. I take the middle 2 digits out, that gives me 76. And I keep doing that, and I get the next number. So you can see when I got to 11 squared, and it gave me 121, so I had to pad it with a 0 to make up to that length again. And you keep going, and eventually the sequence is either going to repeat or it converges to 0. So this number converges to 0, but you can't quite see it, it's fit on the screen. Therefore it's the next number. But there's nothing magic about this one. So if I started off with the number 46, for example, then I'd get 11 out, it's been the next value. So there's obviously a couple of weaknesses with this random number generator in that you can easily predict what the next number is going to be, and also most numbers end up converging to 0 as well. So if we look at, so this is a plot of all the 2-digit numbers, so you can see most of them end up at 0 at the top, or you get a few sort of differences at the bottom there. So the next version is this middle square, not sure, so that sequence. And so this is getting a bit more complicated when you start actually having some state inside it as well. And so this is meant to be quite a fast way of generating a sequence of random numbers. I couldn't actually get it working in C# because it uses unsigned 64-bit long numbers, and it was all getting truncated and not working when I was trying it. And then the version we have in C# itself is it's one by Donald Knuth, and it's a sort of modification of his number version. And again, if you look at it, it's quite complicated, but you can see sort of the basics that's coming from that. But in the documentation, one of the things it does say is it's not a cryptographically secure random number, so you shouldn't be using it for security stuff, because it means to say it's not secure means if it's a danger that looking at a sequence, you can predict what the next number is going to be. So if you want to use a random number that really is secure, you have to use, instead of the random class, you use this RNG crypto service provider class. And it's only got one method, which is get bytes, which is similar to that next bytes method we saw before, where you give it an empty array and it will populate it with a random number. So in this case, my array only contains 1 byte, so I'm just going to get one number out. So it'll be between 0 and 255. Oh, I did it in a loop, did I? But so you may ask, well, why wouldn't we just use this one all the time? Why do we have the system.random? So I thought, well, it's probably because of speed. So I found this tool called Benchmark, which is quite a good way of comparing the speed of 2 .NET functions. So you code up the 2 functions, which I'm just generating 10,000 random numbers in a loop. You annotate it with benchmark, and then you run this benchmark program, and it will run those 2 bits of code lots of times and put out the results for you. So you have to run it from the command line, because you want to run it in beast mode. So this tool runs it for you, and it runs it a few times, and it discards the first set of results, I think, because it's warming up, loading it into memory, and runs it. So we'll just give that a couple of seconds to finish. So I was predicting that the secure one was going to take longer than the system random one, which is why you've got the 2 different versions. And so when I first ran these tests, I ended up actually with the results, they both came up at the same speed. And I ran it again, and they were slightly different, but not much. And the reason was because in my original code, I also had left in console.writeLine and in the both functions. And the time it takes to write out to the console far exceeds the time it takes the random number generator to run. I'll show you the results from last time. So you can see from here that the crypto, the secure version, is a lot slower than the system random one. So if you need a lot of random numbers, then you might want to consider using that one. So, and then we've talked about these different random number generators, and some are secure, some aren't. And so then you start thinking, what makes a good random number generator? How do you decide something's good and something isn't good? And is it just that it's going to provide the same set of values equally? But how do you possibly test for that? Because if you generate one random number between 0 and 6, where you haven't got an equal number of values, and if you generated 5 values before you start counting, well, your 6th one, you don't want it to be the only one you haven't generated yet, because then you're predicting what your random number is going to be. So it turns out there's quite a few different methods of testing whether random number generator is any good. But that's a talk for another day. That's it. Thank you.